Now as you're working through these, some clues on how to approach it, bringing us back to that stuff we were doing last week. Notice that the equations include both an x squared and an x in them. That tells me I can't do it just by like taking the square root of both sides or something like that. So instead we got to go to our other method, which is factoring. So if you weren't sure how to start them, factor the equations. And now as you're doing that first one, and you're looking at factoring it, notice it's just a plain old x squared. That should actually make your life pretty easy on that one, right? Because remember, when it's just a plain old x squared, in order to factor it, you just need to say what two numbers add to the middle number and multiply to the last number. And that one's actually a pretty doable combination, right? You should hopefully come up with our two numbers being 5 and negative 3. So we can then factor it into x plus 5 times x minus 3. But notice this is not our final answer. Factoring is our method for solving it, but it is not the solution. And we're actually asked to solve it. So in order to solve it, remember, we're going to look at each of the parentheses and say, what can I plug in for x that makes that equal 0? Or in other words, actually set what's inside the parentheses equal to 0 and solve it. And so what plus 5 equals 0? Negative 5, absolutely. And what minus 3 equals 0? And so there's our answers for number 1. Continue with the same process. It's just the factoring is a little bit more involved later. Now when you move on to that second one and you're factoring it, notice it's not just an x squared, it's a 5x squared. And we can't just pull that 5 out of everything at the start. So this is one where you actually have to figure out what a times c equals. So 5 times negative 7 is negative 35. So you're saying what two numbers add to negative 34 and multiply to negative 35. Thankfully that one's not too tricky to do, right? Ends up being negative 35 and 1. And so that's what you'll break it up into in order to use the grouping method and then actually have it factored. So go ahead and finish that factoring out if you haven't yet, and then we'll take a look at the answers in just a moment. Or if you prefer, negative 0.2 would also be fine there. Although I do like the fraction. It's got a little bit more style to it. All right, and then for number 3. Well, again, we have a number out in front of the x squared, and we can't just divide everything by that number. So I got to figure out what a times c equals. So ac in this case is going to be negative 10, because we do negative 2 times 5. And so I need two numbers that add to 7 and multiply to negative 10. Although it gets tough to find it, actually. Tougher than it should be. Because like what most of our minds go to first is like 5, there it goes, and negative 2. But that actually adds to a positive 3, not 7. And what we might say, well, what about negative 5 and 2 then? That multiplies to negative 10, but it adds to negative 3. Okay, well, the only other way to multiply a 10 is 10 and 1. So what about like 10 times negative 1? Well, if we add those, we get 9. Or negative 10 times a positive 1 gives me a negative 9. None of them are 7. Is there a way that I could do like 5 and 2? Positive 5 and positive 2 here? No, because then we wouldn't be getting the negative 10, would we? That negative changes everything. And so there actually is no factorization that works for this one. It's not fast, but it is still solvable. But that's only by today's new work. That's by the new lesson that we're going to be going through today. And so the very first thing that I need you to do today is break out your math notes, where of course you're keeping all of your notes together, right? So you can easily find them later. Especially going to be useful today, because I need you to add the quadratic formula to those notes. Now, as you're looking at these notes, a few little detail kind of things. We got the quadratic formula up there. We'll focus on that in a moment. But just so you know, this part down here, it's not strictly just quadratic formula. This is just a good time to bring up the fact that the solutions that we're finding, and that's what quadratic formula is used for, is finding solutions, go by a number of different names. Because solutions are typically when you set the equation equal to 0, the solutions will often be called zeros. But zeros, where it crosses the x-axis, often will also be called roots. And so all of those are different names that are going to mean the same thing here. Now, for the quadratic formula part, notice you got the formula up there. Make sure that you wrote the formula down correctly. Okay? So specifically, negative b. You got to have a negative in front of the b value there. Then the plus or minus. We've seen the plus or minus come up along the way in our solutions. It's now going to be as part of our work as well. And then you have the square root. Make sure the square root symbol goes over the whole thing here of the b squared minus 4ac. And then the fraction bar is under all of that stuff. It's not just under like the square root or something. It's under all of it. And it's over 2a. Now, some of this should seem slightly familiar to you. There should be some echoes to a formula you've seen before here. At least I hope so, right? Yeah. Remember how I gave you a formula before that was x equals negative b over 2a? That's how I found the x-coordinate of the vertex of a quadratic. It's just we throw in this extra piece here to actually be able to find the solutions. Now the part that's going to really scare you probably a little bit though here, you will need to memorize this formula. But the good news is, you're going to be using it here, and by the end of next week, you'll probably have it memorized just from usage. But as you're working, just realize that the goal is to actually have it memorized, because, for instance, in case you need that extra motivation out there, that test that we'll be taking on this unit, which will be right before we go to break, it's a test, which means no notes. And you'll be asked to use this formula on there. So you'll have to actually have it memorized. You won't be able to have it any other way. So be working on memorizing it as you use it going forward. All right, now let's actually use it for that problem that we saw earlier. So earlier we saw this problem. And we knew we couldn't factor it. And basically quadratic formula is what we resort to when it's not factorable, because it's the more complicated one. So if you can factor it, we just do that. All right, so we are going to start this by plugging stuff into the quadratic formula. But of course, plugging stuff in means we have to know what to plug in, right? So like we have to know what the B, the A, the C, all that stuff equals. So let's check here. What's the A value in this equation? Yep, it's always whatever is in front of the x squared. So in this case, it's the negative 2. Remember that if it's just a plain old x squared, then a would be 1, not 0. All right, what is our b value here?
7.
Yep, b is 7, positive 7. And c, what is our c value? 5. Now, you're just starting to learn quadratic formula and starting to use it. So I'd recommend that you actually write that down first. A equals, B equals, C equals, and grab those. That way, while focusing on this big old formula, you don't get distracted and accidentally grab the wrong number or forget a sign or something like that. We got enough to grapple with along the way. All right, so now I actually need to start using that formula. Now, I've been teaching quadratic formula, amongst other things of course, but I've been teaching quadratic formula for 18 years. I say that to point out that if I say that this is a better way to do it, you should probably listen. Because I see the mistakes that get made over and over and over again, and I don't want you to make it. And yet I know, after saying that someone's going to ignore me and go and do it their own way, and I'm going to have to come around and be like, no, do it that way, and we'll fix it. Learn before you make the mistakes. That'll be even better. All right, so when we plug in here, we're basically just going to plug in exactly as we see it. We will not simplify at this point. We are only plugging in. So we go x equals. When I write negative b, I always start by writing the negative. And then I plug the b value into the parentheses. If the b is negative, I write a negative number there. That's one of those little things where some of you are going to look at me like, why do I need to do that? And yet, if you do that, it helps avoid errors. In this case, though, b is not negative, it's positive, so it's going to be 7. I put parentheses around everything that I plug in. It makes it easier to follow, and it helps prevent errors. All right, so it's then the plus or minus part. So we just write the plus or minus. We won't have to separate it into doing it once is plus and once is minus until the very end. Now we hit the square root part. So we start square root. Next up is b squared. Okay, so again, I put it in parentheses. My b value is 7, so I put the 7 in the parentheses, and that's what's being squared. Those parentheses in this spot are especially important. For instance, what if I gave you this? Negative 6 squared. What does that equal? I'm getting two different answers, aren't I? Some of you are saying 36, some of you are getting negative 36. I'll tell you, if you type it in your calculator, it'll tell you negative 36. And your calculator's right, that does equal negative 36. The difference is that most of you, when you see that, you aren't seeing negative 6 squared, you're seeing negative 6 squared. And you're assuming, oh, they must have meant this. But we don't assume in math. You write it the way it's supposed to be. If we write it without the parentheses, it will be negative. And if you type it into your calculator without the parentheses, it will give you a negative answer. And you need to be smarter than your calculator. All right, continuing with our work. Next up, inside the square root is that minus, so it just is a minus there. Then the 4, and then AC. Again, both the A and the C in their own sets of parentheses. I don't want to make that one big set of parentheses because it can lead to errors. Again, I've actually seen these errors crop up today where somebody was writing something, I'll just switch the order around to illustrate. They were saying it's going to be 5 times negative 2, and they did it all in one big parentheses. Well, technically it's right, except that it's really hard to see that little dot, and they had missed it, and they said the answer was 3. And it threw off all their work, and they had to erase a whole bunch of stuff and go back and redo it. I don't want you to have to go back and redo it. So put each in their own parentheses. It helps avoid it. And then it's all over 2a. 2 times, and then the parentheses again, the negative 2. Everything in their own sets of parentheses, everything being plugged in, nothing being simplified along the way, just plugging in at this step. That's all we do. Now that we've got everything plugged in, now we go ahead and we start doing all the simplifying. And a lot of that simplifying is fairly straightforward at this point. Like negative 7 is just going to be negative 7. If it was a negative, well then it'd become a positive number there. The plus or minus, the 7 squared of course will give me 49. But then this is the next part that I need you to pay attention to, because this is where I start seeing some interesting errors here. When we figure out what this equals, okay? I'm multiplying by the negative 2 and the 5. But my question to you is, what am I multiplying by the negative 2 and the 5? Am I multiplying by negative 4 or 4? And that is a really important question here. Now, some of you are going to do it differently than what I say, and you know, it can be done differently from what I talk about here, and it can make sense, but it is prone to error. Because what I'll see a lot of people do is they'll say, okay, so I'm going to do 49 minus, and so I'm going to do negative 4 times negative 2. That gives me 8. 8 times 5 is 40. So I'm going to do 49 minus 40, which is 9. That's wrong. Do you see why it's wrong? Remember that I said I did negative 4 times negative 2. This is one of those things where, after all those years of experience of seeing people do these exact problems, I can say, if you want to avoid errors, treat that as 4 times negative 2 times 5 and keep the subtraction there. Because what happens is we treat it as a negative 4 and then we do the math and we forget that we use the negative, so we write it in again. And we make a mistake. But it's not. If I multiply the 4 times negative 2 times 5, it gives me negative 40. And so it ends up being 49 minus a negative 40. And some of you I know are looking at being like, yeah, but then I got to write another negative. What would you rather write? Another negative? Or erasing all the work you do after this and then having to rewrite it? To me, that seems like an easy choice. It seems like, okay, just write the extra negative now. It saves a lot of problems later. That's my value judgment on the whole thing, at least. If yours is different, okay, but I think this is probably easier, doing it this way. Now that we've gotten to this point, now we can go ahead and do 49 minus a negative 40. I know that's going to give 89. And now that we're at this point, we're at a bit of a crossroads. Because there are some problems of these where we use the quadratic formula where we want to know what the exact solution is. And if it asks us for the exact solution, we'd be done. This is the exact answer for this problem. Now, we call that the exact answer because the square root of 89, it's not a whole number. It's a big, ugly decimal. It is an irrational number. And so it's this decimal that goes on forever. If I punch the square root of 89 in my calculator and start doing work with it after this, I'm always going to be working with some kind of a rounded decimal. So if a problem says give the exact answer, this is what it means. Does this problem, though, say give the exact answer? No. This one says round to the 100th. And if it says to round to anything, that tells us we actually have to do the calculation. Now, doing the calculation, though, can be a little bit tricky depending on what type of calculator you have. So let's see how you would do this. First of all, I'll run through it the first time talking about the graphing calculators. So if you're on a graphing calculator, what you're going to want to type in right now on your calculator. So on your graphing calculator, and if you're on a different calculator, then just hold on, I'll go through your instructions in a moment. First thing you want to do is just type in the top of the fraction. And so that's going to be negative 7. Wait, we now have plus or minus. Well, remember, plus or minus means do it once as plus and once as minus. So I got to pick one and do it. So I'm going to do the plus at the moment. So plus the square root of 89. You just typed all that stuff into your graphing calculator all at once. And then press enter. The trick to this is hitting enter at this point, not later. Because if you try to type everything in, including the divide by negative 4, you got to include a whole bunch of parentheses around the top in order to make sure it comes out right. And it's easy to lose one along the way. But if you do just the top, press enter, then all you got to do is say then divide by negative 4, and press enter again, and you have your final answer. Now, that's if you're doing it on a graphing calculator, right? But what if it's not a graphing calculator? How do we do it then? Well, if you're doing it on a non-graphing calculator, that is likely a scientific calculator, that means you have to know your order of operations really well. Okay? The first thing that I want to do, order of operations wise, is the square root. So on your scientific calculator, in all likelihood, that's the non-graphing calculators, you do the square root of 89 and have that number displayed on the screen. So like square root of 89 equals or whatever your calculator needs to do. Then, I need to do negative 7 plus that number. But of course, if I press negative 7, that number goes away. So, we use what we know. And that is that negative 7 plus root 89, is the same thing as the square root of 89 minus 7. So with the square root of 89 still up on your screen, say minus 7. And so that was the second step. When you've done that minus 7, the number you now have is what the entire top of the fraction equals. So all that's left is to divide it. So the last step, divide it then by the negative 4. And then you get your answer. Whichever method you're using, you should end up getting two solutions, right? Because the other one, to get the other solution, you then redo the whole thing, except instead of this being a plus, you do it with a minus. The two numbers you should come up with are a negative 0.61 and 4.11. All right, and then once you've gotten those, then you know you're good to be working on the assignment that I'll give you here in a moment. But first, one other little detail. I mentioned this earlier, but it's worth actually formalizing a little bit. When the instructions say the words round your answer to something, to anything, doesn't matter what you're rounding to, but if it says to round your answer, you're giving your answer then as a decimal. So you actually got to do the work we just did of plugging it into your calculator and getting the numbers out. But if you see in the instructions the word exact, or the word radical, or even the word simplified, then you know that you need to leave your answer in terms of the square root, which is actually kind of nice because it means you don't have to actually plug it all in the calculator and do all that. You can actually just stop with the square root point.